Hi, everybody. Welcome back to my basement. It's like we never left. Okay, so I wanted to just investigate the electricity that comes out of my wall for a minute. Let's see what we can learn about it. I've got this plug here, which I have cut the end off of, so it's exposed the wires. Now there's three slots here in our outlet. One is a ground, one is what we call the neutral, and one is what we call the hot. The ground exists for safety, and that is what is right here on the bottom, this little round one. That always provides the intention is that it always provides a path for the electricity to follow that is easier, that is lower resistance than a path through your body. The intention is that if something goes wrong with a device you have, and somehow the hot gets connected to a place where you could interact with it, this ground, theoretically, would always provide a shorter path for that electricity than through your body, so hopefully you wouldn't get electrocuted. Now, standard convention is that black is hot, black for death, be careful. White is the neutral, and under normal circumstances, that's where the current goes. It goes out of the power. We could think of it as being delivered from the hot, and then the neutral is at 0 volts and returns the current back to the breaker box. Under normal circumstances, green, the ground, should carry no current. Well, I've got my multimeter here. Let's just see what potential I'm getting out of my wall. So what I'm going to do here is I'm going to go ahead and I'm going to connect this between the hot, the black is the hot, excuse me, between the hot and the neutral. And then we'll get some good separation here so that there's no touchy going on. And tweak this a little bit. There we go. And let's see what we see. Okay, there we go. It looks like it is reading 122 volts. 122 volts. And so, you might say, well, I thought outlets were 120 volts. Why is that 122 volts? And so 120 volts is kind of just an average, really. It's what the power company is aiming to deliver, but depending on how close you are to the transformer, you may or may not see 120 volts. If you're very close to the transformer, like we apparently are, you'll see a value slightly over 120 volts. Whereas if your house is farther down the line, you might see all the way down to 110 volts, although that would be pretty low in the United States. So that's kind of cool. Again, let's check something here. Let's check I unplugged it now. Let's check the potential between the ground and the neutral. If what I'm claiming is true, then we should not see any potential between the ground and the neutral. Let's see. And indeed we don't. We see no potential between the ground and the neutral. However, if I was to go ahead and hook this back up to the hot, what potential do we see between the hot and the ground? Oh, and there we go. There's our 122 volts again. Okay. So that's interesting. Okay, I'm back. Now I have a transformer. I have this one right here, which is kind of an old-fashioned transformer. This is probably, I don't know, 60 years old, something like that. This probably came out of an old radio, possibly an old Hammond organ. I actually don't know what it came out of. But I picked this one out because it has one primary and several secondary. And so remember that a transformer, what it can do is it can increase voltage or decrease voltage of an AC signal. And this is a big part of the reason why in the 1800s there was a bit of a battle, as it were, between AC and DC and what would end up being the standard for the United States of America. And AC won out, and a big part of the reason why is because with AC electricity you can easily increase the voltage or decrease the voltage. Now, this is a more modern transformer, but it's based on a classic design. This is a modern guitar amp transformer. A more modern design is something like this. This is called a toroidal transformer. This one also has multiple primary and secondary coils for depending on what exactly you need to use it for. The toroidal transformer has coils that wrap around like this. So they wrap around this donut shape, and you can kind of see, right? They don't. So in other words, they don't wrap this way, but rather they wrap this way, right? And so remembering what we talked about for magnetic fields, the magnetic field is going to be is very strong on the inside of that. This is almost like a solenoid that's been wrapped into a torus shape. And what this design does is it helps to trap that magnetic field, and it helps it to not influence nearby electronics quite as much. So that's a modern design. Okay, well, let's investigate this old-fashioned transformer just a little bit. And what I'm going to do first is I've got my plug here, and I'm just going to hook it up. I've attached some jumper cables, and we're going to hook this up to the primary side of my transformer. And I have this multimeter here, and we'll hook this up as well. That way we can see what voltage we are sending to the primary side of this transformer. And now we can plug it in and see what we get. And there's that 122 volts again showing up on our primary. Now I just want to check one thing out. I'll unplug it, and yep, it looks like I do have 0 volts. So here we see on the oscilloscope a real nice sine wave. Now we'll take away our juice, back to 0 volts. I don't need to be getting electrocuted here today. So, I did say that 120 volts, it turns out that it's actually current that kills you, and we'll talk a little bit more about that, or does damage, not so much voltage that does damage. What we can do, though, is we can use this transformer to step our 120 volts up or down to a different voltage. Let's see, this one here, let's see what we get here. And we'll give ourselves some more juice. And what do we have there? Oh, it looks like 120 volts on the primary. I'll turn off my oscilloscope here. 122 volts on the primary still, and what, about 7 volts on the secondary. Okay, let's check out another one. What do we have here? Oh, I gotta change my scale, overload. I have still 120, well, we're up to 123 now. 123 volts on the primary, and what's that? Ooh, 397, almost 400 volts on the secondary. So I've just stepped my voltage way up. Now what do we have? Looks like still 122 on the primary, and now we're got, oh my gosh, 793, almost 800 volts on the secondary. So this demonstrates the utility of an AC circuit. I can step this voltage up from 120 volts to, well, whatever I want. And so this transformer has step up coils and step down coils, both. So that 120 volts, I might have to try to kill myself there. This 750 volts, that will drive a pretty large current. Your hands have some resistance. If you're wearing shoes, that has some resistance also. But you gotta be pretty dang careful around 800 volts AC, that's for sure.